Okay, good morning. Welcome to our keynote speaker this morning, afternoon, evening, wherever we are. Just a quick reminder before we get started, if you have not resolved any issues with your papers or in fact uploaded your paper yet, please do so right away. We need to get all of the papers in. I know that the attendees want to read more of the details about the talks and posters this week, so please submit your papers and get editing resolved. If you are not the speaker, please mute your microphone and we'll get started. I'm pleased to introduce Li Ding. He's going to speak to us today on the infrared remote sensing for Chinese meteorological satellites. Welcome.
Thank you. Good evening. Thank you all for attending my presentation. And let me first start with a short video of the infrared payloads on board the satellite platforms. And this is. And this is just a serial satellite. Okay, thanks all. I'll just this is just a video introducing for the satellite of the meteorological satellite and payloads of China, and I'll add another screen. Okay. Okay. This conference is held in Shanghai, and I think this is a big and beautiful city. I've lived for 50 years, and there have been several typhoons during the last 3 months. I mentioned this just because I want to say that China is one of the countries with the most serious disasters in the world. And there are many kinds of disasters, weather distributions, high frequency and heavy losses. In this country, the last decades or so, the number of global meteorological disasters have increased by 46%. And the sustainable development of human economy and society is facing several challenges. In China, losses caused by meteorological and its derivative disasters, including flood, typhoon, drought, storm surge, snow disasters, freezing, forest fire, and etc., and accounting for more than 70% of all natural disasters. Earth observation is a powerful method to monitor the occurrences of disasters. So this image shows there were 8 tropical cyclones distributed all over the world on the same day. And we can study or forecast route based on satellite nethogram. Satellite platforms is the extremely useful tools to deal with the challenges of natural disasters. Various countries make much account of satellite platforms or Earth observations. This is the distribution of satellites with high quantized payloads in orbit by countries according to NOAA. And we can realize global 3-dimensional and all weather and seamlessly observations here. The numerical weather prediction, or just short as NWP, proposed the initial value from model prediction. It needs as much monitoring data as possible to be developed as ECMWC and figured out in this curve. You can see here, the error reduces quickly in the past 20 years and had got a rapid development reduction of initial state errors is driven by more accuracy and more dense observations and improved accuracy and resolution of forecast model and better data assimilation methods. We know remote sensing can provide data all over the world, and the spectral resolution is very important for NWP, whether visible, infrared, or and a microwave. We can see in these curves here. Each channel has its specific wavelength range and in the certain spectral band. The same target has different features in different channel. For this, we can design a target like snow, fog, and dust storm. The more narrow the wavelength is, and the more accuracy as spectral features we can get from the target, and we can see here the observation with high spectral resolution may obtain more details, especially for satellite platforms. In order to obtain more accuracy data, scientists all over the world are constantly developing high spectral instruments for experimental and airborne, low orbit spaceborne, and surrounded to geostationary orbit. It has lasted over 45 years from 1969. And China is the first and the unique one who has such sounder on board 35,800 kilometers away. This page shows the history of spaceborne sounder and NWP models. In recent years, high spectral resolution infrared sounders with thousands of channels have become a major part of the assimilation system of many numerical weather prediction, and provide temperature and constant profiles with a relatively high accuracy and vertical resolution. The airs, the YASI and the CRIS are the best level of spaceborne sounders. They have some thousands of channels like this. Also for airs, more than 22,000. For YASI, more than 8,000, and for CRIS, more than 1,000 and 2,000 separately. And the Chinese high spectral resolution infrared sounder, like the HIRIS, and which is on board the Polar orbit satellite, Fengyun 3, or which is shorted as FY3, started work in 2018. The SNO comparison with YASI and CRIS are very promising. The example of some very uniform SNO shows good performance for this payload, and the profile for the temperature and the profile for the moisture are gained, and for years. To get such a high spectral the resolution, the micron interferometer was used, and it can increase the spectral and the spatial resolution of satellite with the atmosphere sounding instruments, and provide the high spatial density, temperature, moisture, and trace gas profile with a high vertical and the temporal resolution from geosynchronous orbit. And the ECMWF monitored the number of satellites data products operationally. And the figure shows that we can get more and more data from space. This comes to a new era for weather prediction. The powerful computation, the huge data enhanced the accuracy of prediction. And the data from Chinese satellites increased obviously, said Wei Han. And what are we need, and what we need, and what are our needs for observation resolution? First of all, we want image improved, which means high spatial resolution, and this is a high spatial resolution. And secondly, we want continuously monitoring, and which means high temporal resolution. For quantitative remote sensing and different targets, the satellite needs high resolution, high radiometric resolution, and high spectral resolution. There are mainly two types of satellite platforms. The polar orbiting platform means the satellite rotated around the Earth, bypass the polar pole, and can provide a global coverage twice a day, which is a bad temporal frequency. On the other hand, the polar orbiting satellites have the high spatial resolution, so it can be used to monitor and the land surface and atmosphere spectral structure for more details. And the geostationary orbiting platform has higher observation essentially, and like this, it circles with the Earth, and it can always face the Earth, and it can be used for atmospheric vertical detection and lighting detection. But its technical implementation is difficult, such as its pointing accuracy and stability. And we can see we have two main types of orbit. But why do we need the geostationary orbit hyperspectral infrared sounders? First of all, we can see the observation from geostationary orbit can get a large spatial coverage and a higher temporal resolution for regional models. And compared with the microwave sounders, it has finer vertical resolution. And the high temperature resolution observation means we can it can provide critical information for nowcasting, for example, for to the storm forecasts. And now we come to the phone-in platform. The phone-in platform is the name for Chinese meteorological satellites. The order number like FY1 and FY3, the phone-in 1 and the phone-in 3, and like this 3 and there are 4 polar orbit satellites, and even numbers like FY2 and FY4 are for the geostationary orbit satellites. There are totally 19 meteorological satellites sent to the space, and now 3 operational works here now. And this shows we can see countries and organizations are developing hyperspectral technology. And China, this is for the FY3 and the HIRIS for FY3 and the GILS for the FY4, both are the interferometer sounders. Now, China has the hyperspectral atmospheric vertical detection and the capability in both in polar orbit and the geostationary orbit. And we can see it's the first we can see it all these together. And this is the technical properties for the payloads. And the US and Japan send images in orbit like this, and the I and AHI, and also the lighting mapping imager. And China has both images and the sounders on orbit, and for the FY3, 4A and the 4B, and and also has the lighting mapping images on board. Compared with the first generation satellite FY2 and FY4 could provide more observation data and useful information in 3-dimension division for the spectral, spatial, and temporal. It is a challenge to effectively dig out the useful information from the big data. This means here comes a new era for big data for weather prediction. And this is the first spaceborne interferometer that flies in the geostationary orbit to make a measurement of 3-dimensional atmospheric structure. And it's based on the principle of Fourier transform, and located on the first the new generation geostationary orbit platform for FY4. This is just the structure of the FR4, and this is for the gears and the payload. And for the migration structure, and there are many requirements for the platforms. First is the micro vibration isolation, and we can get the structure, and we can handle it with this technology. And another, and we can measure the linear vibration less than 0.1 milligrads, and the angular vibration is less than 5 millirads. And and this is we can measure results of the satellite, and here then we can get the fourth frequency band vibration all day for 3-dimensional spectral data. And we can see here the micro vibration it's good. And another requirement for the platform is the damping several heat alternating environment. And we can see we can heat the deformation lead to the image distorting and distortion. In the 24-hour cycle, the sun shines on the different surface of the satellite, and in turn, and the temperature will range more than 300 degrees, and we can see it will invent the image of the payload, and for the we can get for the optical and for the model, we can get a better imaging quality. And this is the specification payload. And we can see this proof is for the temperature, and these for the humidity. And this is just the concept of the payloads, and for the ground segment. And the observation error estimation is less than usual. And this is the jumping of the gears we can show here. And this figure this is just the potential for the prediction. And this is just simulating for the data gained from the gears. And we can see this is just the model, the working model, the operational model to observe the Earth, and we can see it can just recent impact in the recent typhoon analysis and forecasts. It works like this from west to the east, and you just focus on the same area for the forecasting. And this is just show the temporal resolution of 3 minutes and the results of the minutes. And we can see it the operational model here, and for the temporal resolution. And this is just we can see it the results of the prediction, and to obtain the enhance the accuracy of the prediction. And this is also for the typhoon case. We can see here, and we use the several channels of the spectral resolution. And this also we can see the result with using the data from the gills, the position is more closer to the reality. And this is also for the forecasting. And this is the target observation using it in another case. And here is the time simulation of the gills for typhoon forecast. We can see this is the this is the real routine of the typhoon, and with the data from the gills, we can see it is very close to the real one. This is also okay. The question. This is also we can see it's the first time the temperature and the humidity data in the vertical detection. And we have another payload FY4B launched onboard FY4B launched last June, and we can get many models which are enhanced for the new payload, and we had detectors and interferometers and the cold after optics and the heat controlled enhanced for this payload. And this is just the detectors and the code structure, and this is also for the temperature of the interferometer, and it's the performance of the payload on board, and also the better spectral response for the LW, the long wave bands and the microwave infrared bands. And we can also have the cooperation with Wisconsin for the first hyperspectral infrared sounder.
2 minutes, please.
Okay. Here comes to the end of my presentation, and the girls, the first one working in the geostationary orbit and operating an area of real-time detection, and is have the better spectrification and the new applications. Thank you all. And here's here just comes the institute. Thank you all, and welcome to our institute.
Thank you for a very nice talk. Are there a couple of questions? So people might raise their hand or type into the Q&A. I think it's fascinating, and you're dealing with this equipment that is so far away. We sort of take for granted in the accelerator world that if something is wrong, we can always go touch it and fix it. And you really don't have that option with all these remote sensors. Questions for the speaker? Okay, thank you very much. It was really a fascinating talk. I enjoyed the satellite. It's really come quite a long way in the last decade or so. So thank you for your work. With that, I will hand it over for the start of the next session. Let's see, Enrique, are you